right, without further ado, Andrew Goodale.
All right. Hi, everybody. I'm Andrew Goodale. I'm a software engineer at Wingspan Technology, which is a company based out of suburban Philadelphia. So I work from home in Cranston. And I'm going to talk about some of the fun I've had moving between JavaScript and Objective C over the past few years. I'll get to that a little bit. I came from a web development background, so I brought in some of the styles and the learning from that world when I started doing iOS development a few years ago. There actually is, I think it benefited my iOS development experience to have worked in JavaScript, and especially modern JavaScript, as a functional language, because functional programming is really starting to take off in the Objective-C world now. So I'm going to talk a little bit about the recent projects that I've done, some of the things that have inspired, some of the things from JavaScript and web development that have inspired me in iOS development. Before I go on, how many people here are like total iOS or Objective-C beginners? Okay, cool. And I have feel free to ask questions as I go along. I tried to gauge it so that I wouldn't, give you the fire hose too much, but I have a fire hose if anybody needs it. How did I get here? Well, so I've been doing software development since '95, which was great. Netscape went public right around the time I entered the workforce. For you guys, though, I thought it would be interesting to highlight. So, sort of 2002 to 2007 JavaScript that I did was the on-click equals something variety, and then and that's really like, I think a lot of us who started in that era maybe didn't really understand the language very well. And what's a closure? Like, I would not have been able to answer that question. I was paid lots of money to do web development, and I really didn't know kind of an important fundamental part of the language. So then I kind of say 2000. So that sort of was VC before closures, and then 2007 to today is after. I don't know what the D is or something. I started doing ext.js development, and so I started really and that uses some, but not. That still kind of approaches JavaScript from a Java kind of point of view a little bit more, but they do kind of go down the functional path a bit more. And then when I started with Objective-C, coming into that also from Java, it's a really dynamic object-oriented language, even though it's C-based or even though it's built on the C family. So it's been it's an interesting experience to go through. And that's even sort of separate from Apple's frameworks, which have their own kind of inspiration and design patterns. Just kind of do a quick, simple table of the two languages, some of the highlights. They have a lot of similarities in terms of basics, how you model things, how you get things done. So for objects in Objective-C, in JavaScript, an object is a hash table. You can add properties, to it and remove them. Objective-C also has a way of dealing with objects as a kind of a property bag. They call it key value coding. So I'll talk a little bit about that. They have Objective-C now has functions as almost first-class objects. I'll say they're effectively an object. You can't really add properties to them, but they capture state like a closure of JavaScript does. So they get you a lot of the way there. It is loosely typed Objective-C. You can use the strong typing of the compiler when you want to, but you can also just make it has an object equivalent of void pointer or a Java lang object. So you can kind of treat things pretty dynamically. And getters and setters, it will generate those for you like JavaScript can. And it has this, as I said, it's a dynamic language. So in the same way that you can apply you can call a function arbitrarily, you can under the covers, every method invocation in Objective C is a this Obj C message send call. So everything is thunks down to one single C routine, or actually there's one for calling the superclass. So there's actually a lot of logic in figuring out what C function to call when you invoke a method. And there's actually ways where you can help the runtime decide that, and even do things like when someone calls a method on you, you can forward it on another object, and under the covers, transparently from the caller having to know. So it's pretty powerful. And they make a lot of use of this in UI programming. I didn't really mention this, but I think there's a lot of benefits in UI development to that kind of dynamism. I think that's why like C++ UI frameworks, especially in the late 90s and stuff, always had horrendous issues trying to be, they're very hard to use because everything was statically typed and you had to, it was very rigid. Whereas UI, you kind of want the flexibility. Like JavaScript is nice because sometimes you just want to have the flexibility to treat things generically or just be dynamic. So this language really helps out with that. Okay, so quick overview. So as I said, it has a runtime. It was inspired by Smalltalk, and Smalltalk was big on the message passing metaphor. The famous Alan Kay, who coined the term object-oriented programming, what he meant was objects sending messages to each other. He was really talking about very loose coupling, not like C++, not even like Java. MVC is a core part of that heritage from the Smalltalk world. So the iOS frameworks and the Mac OS frameworks are really built around MVC. One of the negatives has been manual memory management. So like C, up until actually only like about a year and a half ago, on iOS you had to manually retain and release objects. And the Mac has had garbage collection for a little while, but a lot of people don't like it. So that's definitely the biggest shock coming from web development is now you're thinking about it, and you still have to think about it because even though Apple has created a automated reference counting system, you still have to be aware of when two objects hold on to each other, then they'll never get released. So that is the worst part of the whole thing. And I'll talk a little bit about that because blocks make that even a little bit more awkward because of the fact that they're closures, so they're capturing state, which means they have to maintain references to objects. So they get into you have to mentally think about, okay, now my block is holding a reference to this object, and I'm holding it, and if I'm holding a reference to the block, you can have lots of problems. All right, so here's some I'm going to give you the kind of the 5-minute sprint here for this, so that we're all on the same page. It's some of it is kind of bizarre looking when you first see it. The top part here, so you define a class by this syntax at interface. That's the interface of the class, and then you can define properties, which are kind of like official getter, official fields, public fields that have getters and setters. So they're not like struct member variables. They're like fields that have a getter and a setter. You can have static methods, which the plus indicates a static method, and you have the minus indicates an instance method, and then you have parameters, with types. So this part looks like C. ID is the generic. This is some object of some kind. It's sort of untyped. This is the untyped part, the dynamic part. And then you can have interfaces which are just to define a set of methods that can be implemented by arbitrary, one or more classes. And interestingly, unlike Java, the protocols can have class level methods, which means that you can have different classes implementing interfaces as well as the instances of the class implementing interfaces. It's kind of cool. Very useful feature coming from Java development. So that would be in the header file, and then in a implementation file you have this block, implementation block, and then so synthesize creates the getters and setters for you. So that's a compiler feature. You don't have to use it. You can hand code them too. And then you have your static method implementation here, and the static method can, this is once you're inside here, it's you can use all the C functionality, all the C libraries. So you can call functions that are just C functions like this, self is the equivalent of this. This is all comes from the UK, so the guy was English, so he used self. The instance method, similarly. Now, the most kind of bizarre part of the syntax is that the bracket, when you want to call a method on an object, you use these brackets. So this says send the run, call the run process method of another object on another object and pass in this, the one argument notify. So if we go back to that, assuming that if we pretend that object implements this protocol, it has a method run process that takes a string, which is a name. So, this code here is calling it. Now notice that this is untyped. So actually, I don't really know if this object implements the protocol or has the method. So you won't get like JavaScript, you won't get the error until runtime when somebody passes in something else like a file or something, and this fails. So there are ways to test this though. Just like in JavaScript, where you can say if another object dot function. You can there's a method that you can call on this that says, does it respond to this message? And so you see that use. So you can use that kind of pattern where you want to ask an object, hey, you can ask an object, do you implement the whole protocol? Or you can just say, hey, do you implement this, do you respond to this method? So similar style there where you can let the compiler, tell the compiler, don't worry about it, I'll figure it out. And then, here's the syntax of the setters and getters. So this one would be getting the value of my num, which is one of my properties here, adding one to it, and then setting it back on myself. So that's the funky syntax. It takes a while to get used to. What you will find is that the method names are all very oriented around like spoken English. So this is an example from the file manager API that's in the foundation framework. So the method to create a directory is create directory at URL with intermediate directories, attributes error. So especially this kind of terminology with blah 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 is a very Objective C style of describing things. What's cool about this, if we compare it to JavaScript and some of the styles that people use in JavaScript now, a lot of times things in JavaScript will take a object literal and kind of do a named argument style on their own, right? So you can almost look at this. You can say, well, in JavaScript, I might have written something that's like create directory. Here's the URL with intermediate directories true, attributes, as an alternative to just the classic create directory, bang, 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 right? And then this one, people like this because it's informative. It tells you what's going on, especially when you're passing in Booleans, right? This is how many times have I seen, true, false, true, true, undefined, like, oh, that's helpful. So this is a great, and so Objective C kind of is sort of built this way. This is the only way to do it. There is no, colon, colon, colon kind of thing where everything is written out like this. So you get these horrendously sometimes funny names, but it's very conversational. Yeah.
I noticed that you aligned everything on the colon there.
Yes.
Is that like a style convention?
That's a style convention as well. Yes. The Xcode will do this for you if you hit return. It will align the colons there.
Huh.
It's actually, I do find it makes it much easier to read than and I think it's because also a lot of times these can get very long, so you're not gonna have enough screen width even with today's widescreens to read it. So so that's what it does, and it also kind of matches up sort of with this style a little bit, not aligning the colon. But yeah, so stuff like this, you come back to JavaScript after doing this for a while, and you start doing things like this a lot more. The other thing, I don't think I mentioned it, the other thing that's interesting too is that passing other information around with these hash, with what they call dictionaries in Objective C is also common. So I think I'll show that a little bit in a second. So in terms of like an object model, like data modeling, so in JavaScript I might have a constructor function that and I have sort of an informal object interface here that has a name and modified date and a child. Maybe this is a reference to another child object or something like that. And I can do new, and I can set the name using the array the bracket notation, or I can set it using the dot notation, and I get that. So we've all seen that, right? That's so kind of in Objective C land. This key value coding kind of gives you a flavor of that. So in kind of the equivalent of what I was just showing here is I got this my object interface with name, modified date, and a child, and sort of don't worry about the strong. That's the memory management thing, and I can talk about that at the end if you guys want to go into that a little bit. But here, here's my creation step, and so I'm using the class and saying allocate one and initialize. That's kind of the common, that's like new in Objective C. And then now, and notice here I'm doing ID, so I'm not even using having the compiler help me at this point. I'm just treating it like a generic object. And key value coding allows me to do this. It says I can set Andrew for key name, and I can set Hannah for a key path, child.name. So this will actually dereference the child property and then call set value for key on name of that. So it's kind of like, it's basically doing what I was doing here. It's the same style. And so that's pretty cool that you can do that. It'll like travel down and go through your object graph for you. And then I can use the dot syntax. This is kind of slightly erroneous because the dot syntax here only works if this is a my object pointer. If it's not, my only option is to do this value for key, which is the get version of that. So this is like the bracket notation in JavaScript with name, and this is sort of this requires the compiler wants to verify that there's really a name property on what you're talking to. So, any questions so far? Yeah.
Instead of doing value for key, could you also send the name message to the my object? Would that be the same?
Yes. Yes. Right. I could also do my obj name close bracket. Yeah. Yeah. The dot syntax is an alternative to the bracket, method syntax. And it actually doesn't even, it basically will call any Objective C method that takes no arguments and returns a value. Some folks in the iOS community don't like this syntax. They feel like it is corrupting and it's not clear what it's doing. So they tell, some style guidelines say just, always do my object bracket name, close. I don't find this to be that bad, but it's like anything, you have to be careful. I haven't been bitten by it yet, so this is actually a more another example that shows you an alternative that the dictionary object, which is basically the hash, the hash map, or like a JavaScript object, is just a name value pairs. The dictionary object also is key value coding compliant. So when you call set value for key, it puts those keys in the dictionary. And then you can do, I can put another dictionary as the value for child, and then I can still do the key path one. So I can set child.name, inside the name property of this dictionary. So it works the same. So that's the cool thing. Now you can't do the dot syntax, right? Because the dictionary definitely doesn't implement that. But like you were saying, and you couldn't do the name bracket one either because it doesn't implement that method. But it does do value for key. So if so a lot of times, what they call duck typing, right, where you want to kind of treat something, you want to get the value of something. And like JavaScript, I used to use this a lot with things like, maybe I have an HTML option that has value in text properties. Maybe I just have an object that has value in text, right? Sometimes you just want to deal with things sort of generically. So if you use value for key, you can basically treat the object as, this could be an instance of a dictionary, it could be one of those my object things that I showed you, or it could be something totally different that just has a name property, or a method that's name with no arguments. So Objective C, the runtime will actually try several different techniques to make this work. So even it goes so far as if you define the old-fashioned way with just a field, like a struct member name, it will even dig in and get the memory and sort of return it to you. So it's pretty cool for that. And an example here. So I think I'm just showing you that. So I can have a my object or a dictionary, and I can pass those into this, and they'll both work. Cool thing you'll notice here, this is just very recent, that they've supported this sort of JSON-like syntax now. So you can define a dictionary and do name colon value, just like in JSON. And the same with array. You can do the @ sign and then a bracket and then a bunch of objects to make arrays. So it's definitely, this language is getting influenced by, by JSON and by web development, I think, or by the need for mobile development, I guess, to work this way. So it's kind of cool. And that's why I was saying you see these a lot as method arguments, to pass in additional information, because it's like you can really easily pass in more stuff. So why is this key value stuff cool? Well, when you read JSON, so when you're dealing with web services that return JSON, when you deserialize the JSON, you get dictionaries and arrays. So the fact that they're key value compliant means that, like I said, I can write stuff that deals with them as well as my strongly typed objects, and I can go back and forth between them pretty easily. So that's one example where it makes a big difference. Or if you want to slowly migrate from, a lot of people will recommend that you not use dictionaries and arrays for your main data model. You want to get that stuff into strongly typed classes that you can unit test and validate and all that, which is good advice, but you might kind of migrate there over time. So being able to kind of go from one to the other and having them both speak common languages is very helpful. That's definitely a benefit above and beyond JavaScript, where you can start to, when you can define the classes in your data model and start to add things like validation and other goodies that you don't see as much done in the JavaScript web development world, at least not the one I've been with lately. So then another side of this is key value observing, which is now I want to watch for changes to these properties. And this really makes sense in the MVC world. So, I might allocate an object, and then I want to add myself as an observer for the name property, and I want to get when I get notified, I want the new value of the name property. And so now if I set the name here, the runtime will call a special method that I implement, which will tell me, hey, this has changed. And whereas this is very useful for your common kind of MVC style architecture. This is iOS specifically, where you have your custom model objects here, and you have some kind of controller that's like manages some screen in your app. Then you have one or more views, and this is tying the two together. So the controller can add observers to your model for various properties, and then when these get updated, it sends this message, which the controller receives, and then the controller can, update the views or whatever based upon that. And this is really useful for, especially when in iOS, where you have the classic example, of the master detail. So you have some controller that has a list of all of your, tweets or whatever, and then if they, the user dives into one and they change something about it, now not only does that screen have to change, but the listing might have to change as well. So both, the controllers one that shows the listing, one that shows the detail view, will both observe and can update, get notified when whatever your data model has changed. So totally very useful. In the Backbone, so we started to use Backbone in my day job, and so Backbone is obviously built around things like this as well, and EXE.js was good about this too. So a similar thing might be that I might have my object type extending the Backbone model, and then I can create one, and I can say, well, if the name change on the name change event, or on a change event for the name property, call my function here, and then I can set the name here and have it to do its thing. So this is kind of the JavaScript equivalent of what we just saw on the other slide there. It's a little more concise, but same kind of effect. Okay, so extending objects. So one of the things I thought was really cool about JavaScript was the ability to add methods, essentially, or basically manipulate the prototype of an object, or just add properties to an object, whatever. But being able to manipulate the prototype to add additional functionality that wasn't thought of by the person who wrote the framework. An example might be like, I want to serialize ext components here. I want to kind of have a standard way to serialize them to JSON or something. Like I'm going to save them to DOM storage or something, and save the view state. So I can do stuff like that. I can add these methods, and then I can call it. And it's nice because you don't have to make these parallel class hierarchies that have your methods on it, and then have kind of these adapter interfaces. Like Java is terrible with this, because if you want to do this, you have to kind of make sort of wrapper objects or something that you can't change a class once it's been created. So Objective C has kind of a similar thing. It's called categories. Categories are a way to, ostensibly what they're designed to do is to help you categorize the functionality of a class. So like you might have on a string class, you have your usual string manipulation stuff, but then let's say you want to do, what if you want to do encode the string for URL encoding? Like you wouldn't really want to put that on your main string class, so you might make a category called NSString URL extensions, and then you could put all the URL stuff in there, like make an entity, blah blah blah. But that pattern can be extrapolated out to things that are even sort of less related, but still important. So like serializing to JSON, right? That's something that back when they wrote these classes, they didn't foresee, but it's very useful to be able to add functionality to the class to be able to do that, and then actually have it be something that can be overridden. Like these are just like class methods. You can override them in subclasses, and it all works. So you can add your own polymorphism to somebody else's library, which is tremendous, because especially in this world, there's a lot of open source, but there's a lot of closed source. Like all of Apple's stuff is closed source, so you can't go in and add JSON functionality this way. But what that means is that once I've included, so that assuming that this is in a header that says, okay, objects have this method, and I'm going to override it for views and do something different. Now, if I include that, now the compiler will happily say, oh yeah, you want to call WSPT to JSON on this view? Sure, that's great. And it'll figure out how to call that method and bind to it. The WSPT here, this is my company prefix. So you probably know with the protocol modifying the prototypes, if you don't do some kind of namespacing, you risk blowing up somebody else's modification. So in Objective C, they always recommend you prefix your method names on a category of, like, when you're modifying somebody else's code, use a prefix so that your modification won't stomp on somebody else's modification, right? Because one day Apple might add to JSON, right? And then that would be pretty bad if your code started running. Somebody upgraded their phone, and your code now stomped on Apple's code, or something magical happened. So this is, I think, good advice for the JavaScript world. If you're going to modify prototypes of other stuff, prefix it. Then it shouldn't be a problem. Okay. Anything? Questions? Yeah.
What's the differences between category and extension?
Class extension is So class extension is when you leave this blank, and it's really designed for making a private method. So one thing I didn't really highlight here is that there's no concept of, there's a very weak concept of public and private in Objective C. And what you have typically in Objective C, the style is to, let me see if I have something here. Some kind of controller. Yeah, so if I have a controller here.
Can you zoom in a little?
Yeah, sure. Full screen? No, it's not. I thought it was control scroll.
It's not like Command Plus or something?
Yeah, I tried Command Plus. It wasn't happy with me, so. It's actually very big. There we go. Whoa. 36 point, anything? There we go. All right, so, and what I'll do is I'll get rid of this. So this says, so I have this controller object here. That this is my main public interface. So it says I extend the UI view controller class. I implement this protocol, and this is the name of my class. Now, what I do in here is set this is a class extension, so it has this open close parentheses. So it doesn't have the category name in there. And this says, this is essentially like the private section of your class. So everything in here is, so there's, as you can see, there's some private fields in here and private methods. So, and it's in, you know, not only is it in the M file, so it's not even exposed to the outside world, but this is effectively, this is a class extension. So this is what it's commonly used for. It's just to define the private interface to something, and that. But you could put this in another header file and then include it, you know, to share a private API with, you know, other classes in your framework without making it public. So that's kind of what they used to do. They used to actually just have a naming convention where you put the word private in there, but now they do this. Or they recommend this. Does that answer the question?
Yep.
Oh, I started my elapsed time back over. That's too bad. All right. So now the big change and the thing that really, from a JavaScript perspective, makes the huge difference is blocks. Blocks are a pretty big subject, so and I don't want to push you all to sleep too much, so I'm just going to try to go over them quickly. So just ask any questions that, you know, if you see something that is confusing. So it's it's essentially like a function object in the C level. So it captures local variable state. This is the important thing. So it is a closure like a JavaScript anonymous, you know, declared function can be. But then you can, because it's an object, you can make it the property of an object. You can pass it around as an argument. You know, you can even introspect get bits of information about it, although it's pretty limited in what the APIs are. You can't. There's a very low-level API to figure out like what the arguments are and stuff like that, but it's not really something that is designed to be dealt with day to day. And it's kind of like C function pointers syntax, which is kind of a little hard to read. So here's an example of kind of a simple kind of common use case in the iOS world. This might be like my controller might have some kind of refresh button or something like that. So some user hits the refresh button, and I'm going to get the table view, and I'm going to get some reference to my server, you know, API, whatever that is, and then I'm going to say, get me some data at this URL, and here's the callback. And so this is a block, so that little hat is the sign for a block, and the block takes a dictionary, and there should be a parenthesis there. Sorry about that, and an error. And so this is going to go make a network request and call me back, just like with, you know, the Ajax libraries that we all use, and call me back, and then I can, inside this, I can reference, you know, either of these two variables and, you know, do something with them. So I can also reference self if I want to. So I can reference member variables in this class, and, you know, whatever I need to do. But that's you know, there you go right there. Is like, this is like something that you would see in any kind of web application as well. So another example where it's used is animations. So the UI kit is great for animations. It has a really easy API. So imagine that somebody does something, swipes or whatever. I want to hide my table. So I can get my table again, and let's say that my table's in the upper left corner of my view. I can say animate with a 3-second duration, and here's the block of animations. And this animation is going to set the left frame to -500. So what that's going to do is it's going to say, for this 3 seconds, it's going to animate the frame moving from left 0 to left 500. So it's going to take 3 seconds to slide out like that. You could also do other things like, if you wanted it to fade, you could set the alpha, which is normally a 1 for fully drawn, set it to 0, and it will fade out to nothing. So this kind of stuff, great. I mean, this is just this was a little bit more confusing to do before blocks, but now this is just a lot easier to read kind of what's going on. And the cool thing is that this within a block you can call other blocks. I mean, it's just like in JavaScript, you can nest these things to your heart's content. And finally, this one here is sort of the example I was saying about that they're an object. So you can have a property, not only in addition to your name, you can have a property that is a block. And the property, so here's some of the weird syntax that you inherit from C and C function pointers. So that the little caret here says it's a block. The property is called name changed, and it's a block that returns nothing and takes a reference to a my object. So now, assuming that somebody sets this, that inside this implementation here, I can have my setter, change the name, and then I can say if the name changed block is set, call it. So there's again, this is sort of like another style of JavaScript where you can say, hey, do you have this function? You can do the same thing with blocks. So yeah, so it's pretty cool. Now you see stuff like copy and stuff here. So again, the memory management is basically the block has to be referenced, copied around. And I said I can get into that if people really want to later on. Any questions so far? Okay. So Grand Central Dispatch is this other library that helps you execute blocks. And this is kind of what these networking libraries and things are built on, where it's sort of like, I don't know if anybody's used web workers, but it's kind of a way to break up your function, your units of work into things that you can call, or basically call and schedule in different ways. So you can say like, call this function in 5 seconds, call this function on this, over here on this other queue, and the other queues may be implemented by other threads. So the operating system will figure out, given how many cores you have on your machine, how it should distribute the workload of all these queues across threads. So you don't have to actually think about threads at all. You just think about my queues of work, and then you just put stuff on these queues. And so like an example of that, so like this networking library that's block-based, called AF networking, very popular in iOS development. When you make that request, get me this URL, it goes into a queue. And then when the response comes back, if it's a JSON payload, it puts it into another queue for deserializing from JSON into these Objective C dictionaries and arrays. And then after that's done, it has to call success or failure. Call your block back that says, your function's call back for success or failure. It'll put that onto a queue. And it'll, usually by default it's the UI thread, but if you wanted to, it could be a different thread. So all of these things are queued, and so that means that, so for example, the JSON parsing might be, if you're getting back, a megabyte of JSON or something, you don't want the UI thread to be stuck parsing JSON. So having this on a separate queue means that the operating system will use another thread, or will decide what's best for, it definitely won't be the main UI thread that does it. It'll decide how many threads it's going to use. Stuff like that. It's very, very cool. I think that's what helps make the UI so responsive in a lot of iOS apps. Because like JSON parsing does not have to be done on any thread. So things like deferring a call, right? I talked a little bit about that. So, with _JS, and it's always sort of been traditionally pretty easy to do something like this in JavaScript. I can say, call this method, I can say defer it, just call it, next time through the event loop. Or I can say, call it, in 1 second. That's pretty straightforward. So now you can do stuff like that with blocks. So I can have a block here that is going to effectively do window.alert, and I can say dispatch this asynchronously, which means just queue it up and call at some point in the future on the main queue. That's the UI thread. So that was like the first one we saw. And then if you want to give it some time, you can say dispatch after, and then you can say this is in nanoseconds. You can be quite precise in this API. So this is 1 second in nanoseconds. So dispatch this in 1 second on the main queue in the block. So yeah, you can get pretty blank-brained if you want. So it's not pretty. It's C. And it looks like C, but it works well. But the patterns are similar. And then you've got the usual functional programming stuff, right? So we might probably all use something like with a JavaScript array for each, pass in a function and it gets called for each one. Well, now with blocks, Objective C has this as well. So you can do this enumerate. Here's the syntax I was talking about. So you have the little at bracket to make the array, and then I can call enumerate objects using blocks. Now, this is kind of the difference, like I said, of the way that Objective C API reads like English. So they called it for each. Apple decided to call it enumerate objects using block. But this is effectively doing the same thing. One of the cool things is that they have some interesting with this whole dispatch queue thing and threading. They have some cool little add-ons that they do. So there's also this enumerate objects version that says I can do it concurrently using the block. So what this will do is actually, so like if you have an array that's 5 million items, this will actually take the block and essentially divvy up the array and queue up that block to work on subsets of the array. But it'll queue them up so that they can be run in parallel on different threads. So that's pretty wild. That's, assuming you have to make sure that the block isn't accessing some kind of shared state or something like that, but assuming that you were doing some kind of heavy computation, it's right, the array class is doing this for you. This is so it's pretty cool. I don't know if people do a lot of stuff like this on an iPhone. Maybe on a Mac, it's more common, but it's pretty neat. So, last thing I want to talk about is a little bit about another sort of style that I've used in JavaScript, which blocks make it easy to do, is the event style of programming, where you have widgets or controls or things that fire events to say what's going on, and people hook them to do different things to respond. So with blocks, we have an easy way to do that now in Objective C as well. And so I created this category that I called the events category, and basically, and I made it on NS object. This means this is the low-level base class. That means that every Objective C object that I use, I can call these methods on. I can use this API, and I have things like on event, call the handler. I have onEvent once, so if I want to just have one of those, fire once and forget kind of calls, I can do that. Or I can unregister for the event. And then the object itself has a method to fire an event or fire an event with arguments. And here's my block that says all of the event handlers are a block that takes the object, which is the source of the event, so the thing that's firing it, and then any optional arguments as a dictionary. So now I can do things like if I have a table, and the table has a cell that shows you a pick list or something like that. Well, no, I'm sorry. This is this is my pick list, and maybe when you're setting up the pick list, you want to be able to kind of control how your data is rendered. So when the picker is making a cell, now I can fire an event that says, I've created a cell for this row, and my arguments are the cell, and these are string constants, which are the names, and then the option, the picker option that the cell represents. And now anybody could, sort of like a before render method might be in a JavaScript framework, gives you a chance to doctor the cell in some way, change colors based upon something, things like that. But I can do stuff like this, and I don't have to worry about making interfaces and or even having kind of the question of like, can more than one person respond to this, stuff like that. So I kind of like that kind of flexibility of having things be kind of loose for UI development, be kind of loosely coupled like this, so that you don't have to define a lot of interfaces and kind of make a lot of hard decisions up front that you might want flexibility on. And so lastly, I'll just point out a couple of projects that people are interested in looking more. So I mentioned AF networking, which is a popular block-based networking API. There's also this thing called Blocks Kit, which adds a lot of stuff like MapReduce and alert, show an alert and call me back when the user clicks OK. And then to toot my own horn here, I have a framework that I built a couple years ago that lets you kind of treat a JavaScript object as an Objective C object. It uses some of the runtime features to let you do that. It basically makes any JavaScript object in your embedded web view key value compliant, so that you can do set value, get value on it. You can actually set blocks to look like functions in JavaScript, and so you have two-way communication. And it uses some of these same principles, like, hey, these languages are pretty similar. It's just Apple didn't do all the work to make the UI web view on iOS have all of these hooks, but the models are similar. So if anybody wants to see that later, I can show that too. Okay, that's it. Is anybody still awake?